You need to take a break?
Yeah, I can use a couple minutes.
All right.
Thanks. Come on, Cash. Let's go inside.
Probably should have turned the recorder off. But if I do it now, I'll get an extra recording.
Are you still there?
I'm still here.
Okay. Things were very still. I thought, well, sometimes I think I just go away.
Yeah, I was waiting for Catherine to get back. I really don't know why they labeled this practical circuits. It doesn't seem to have anything to do with actual circuits, but
Hmm.
uh, I didn't name it.
Okay, I'm back. I'm ready.
All right.
Thank
Like
you.
I was just saying, I don't know why this is called practical circuits, but we'll go with it. We're going to talk about equipment, really. Um, so, talk about transceivers, which is what they call things nowadays, because it's a combined transmitter and receiver. Back in the old tube type days, you could get
Mhm.
separate transmitters and receivers in separate boxes. Uh, I don't know anybody that uh, builds them that way anymore, except for some homebrew stuff. You know, people that build their own sometimes build them separate. Uh, there's also a thing besides a transceiver that sounds similar called a transverter. And it's really a device that allows you to convert a VHF or UHF signal down to an HF band signal. So I think in most cases they probably operate on the 10 meter band, which would be around 28 megahertz, and allow you to uh, transmit and receive in the VHF and UHF bands. It's normally a separate box that you have to attach to your radio. So what is a transceiver?
It was alpha.
Alpha. Mm-hmm.
What device converts the RF input and output of a transceiver to another band?
Charlie.
Charlie.
Okay. We talked about different kinds, that handy talkie or handhelds. In most cases are 5 watts. I think there's few out there that claim they're 8. It's not a lot of difference power-wise. Most mobile radios I've seen tend to be 50 watts, and base stations tend to be 100, at least in the HF band. Now, when you get up to the VHF and UHF, it's usually less. My 9700 will do 100 watts on VHF, but only 75 watts on UHF and 50 watts on SHF. You can use an external power amplifier to get increased power, and you can go up to the legal limit, which in most cases is 1500 watts. So that can make a big difference if you're trying to get long distance communications. And most of the separate RF power amplifiers will have some kind of a mode switch that allows you to set the output power depending on the mode that you're operating in. Older ones, you would set the band that you're operating at, whether you're doing 160 or 80 or 40 or whichever. Some of the very new ones do a lot of this stuff automatically.
Mm-hmm.
You know, connect the thing up, turn it on, and away you go. Of course, it means they're not cheap. So what device increases the transmitted power output from a transmitter?
Bravo.
Bravo.
These were popular back in the CB days too.
Mm-hmm.
People would run a linear in their car,
Mm-hmm.
probably illegally. What is the function of the single sideband CW-FM switch on a VHF power amplifier?
Ooh, Bravo.
Yeah, bravo.
Very good. Okay, when we talk about transceivers, some of the important things you need to look for is the sensitivity, which is basically the ability to detect a signal, and the signal level. So the higher the sensitivity, it means the lower signal level it can receive clearly. In some cases, radios will have a built-in RF preamplifier that you can select. In some cases, two, like a 10 dB or 20 dB gain. Or you can have an external preamplifier that you install between the antenna and the receiver, just like you would a transverter. The other important thing is the selectivity, which is how well it can discriminate between two or more signals that are close together. So if you don't, you can have very good sensitivity and pick up all kinds of signals, but if you had bad selectivity, you won't be able to single out an individual signal. You'll still kind of get mixing from them or overlap. So you really need one that has high sensitivity and one that has high selectivity. And obviously, the ones that have the best sensitivity and selectivity are going to be the most expensive ones.
Of course.
Yes.
So which term describes the ability of a receiver to detect the presence of a signal?
Bravo.
Yeah.
What describes the ability to discriminate between multiple signals?
Charlie.
Charlie.
Where is an RF preamplifier installed?
Alpha.
Okay, a little bit about different types of receivers. This is just for historical purposes. I don't think there's a question, as I recall. But one of the original types of radios was, or receiver, was called a tuned RF or TRF, where it had multiple stages of amplification that were all tuned to the same frequency. And it was kind of a mechanical nightmare where you had to gang the tuning capacitors all together stuff and make sure that they were oriented correctly. And it had very good sensitivity. It had very bad selectivity. But it was very simple. Then came what was called the super heterodyne, where heterodyne just means that you're mixing a signal with the received signal that's the same frequency. And actually that's called a monodyne. So the result of that would just be the baseband signal. Those don't work very well, so they went to the super heterodyne, where it may have multiple stages of mixing, and in each case the local oscillator that's mixed with the signal is offset by a difference in frequency. So the output of that mixer is going to be what we call the intermediate frequency, which is usually much lower and easier to amplify and then further demodulate. So a simplest super heterodyne receiver is what's shown there, where you may have an RF amplifier or preamplifier before the mixer. The mixer just essentially down converts the signal to a lower frequency so that you can amplify it in the IF amplifier and also run it through a filter so that you only pass the bandwidth that you need for that signal. Like if you're doing single sideband, you'd have that filter set to about 6 kilohertz or less, or 3 kilohertz for just one sideband. If it was CW, you'd probably have that filter set down to about 150 hertz. Newer radios have gone to what we call software-defined radio, and they're kind of back to direct conversion where all this started, where you take the signal and you convert it directly into baseband and then operate on it in software. So you take the signal and you run it into analog digital converters, where you now have a digital signal that's at the baseband frequency, and or possibly some very low intermediate frequency. And you do all these digital operations on it like you would have done in the analog radio, except in most cases you can do them much better in software. You can have filters that have almost look like a square wave, and a lot of different kind of noise reduction techniques and other filtering. So I'd say almost all of the newer radios are all software-defined radios, either totally or a hybrid. And what I talked about in the superheterodyne using a mixer, and all a mixer is a circuit that allows you to input two different frequencies, and it outputs the cross product of those. So in a very simple mixer, you would see your local oscillator signal on the output. You would see the upper and lower sidebands of the modulating signal that's on the input signal as part of the output. And you may have some other harmonics, but the basic thing is just going to be the carrier and those two sidebands. I don't know if I have a chart coming up. Oh, yeah. We'll go over on the right where we're doing an up conversion. So the output that we would see is that local oscillator frequency and the baseband signal shifted above and shifted below. And the one on the lower side is really a mirror image of the upper one.
Mm-hmm.
And those are what we call sidebands. And when we talk about single sideband, what we're going to do is remove the carrier and one of the sidebands. So we'll only operate on one of them. So it has much narrower bandwidth, and all the power is in that particular sideband. So it makes it much more efficient. And you get a higher signal to noise ratio. In the other case, we're doing down conversion where you would generate with the local oscillator and the RF. The results of that is going to be this IF frequency that you're going to operate on. And then you would further do another conversion to get the audio out of that. So which of the following is used to convert a signal from one frequency to another?
These aren't mixers?
Mixers.
Bravo.
That's all a mixer does is mix two and generate a third.
Gotcha.
We talked about having a local oscillator. Sometimes it's called your VFO or variable frequency oscillator. This is kind of a typical circuit of a little simple transistor one, which just generates a, in this case, it's not a variable, but a specific frequency. So what is the name of a circuit that generates a signal at a specific frequency?
Delta.
Mm-hmm.
Okay. The next piece that we need in a radio for transmission is a modulator circuit. And the modulator circuit kind of works like inverse of the mixer, where we take the baseband or speech signal and mix it with a carrier to come out with a modulated waveform. So in the case of doing amplitude modulation, you can see that that top animation is the modulating signal or the voice signal. In this case, it looks more like a single tone because your voice is very erratic.
Mhm.
And the amplitude modulated signal that's generated. So instead of a constant amplitude, you see the amplitude varies, but the frequency is the same. It's a constant frequency with varying amplitude. If we're doing FM modulation, we have the reverse. We have a constant amplitude and we vary the frequency.
Gotcha.
Question?
Nope.
This is just another chart showing kind of the same thing, except there's no animation. So which of the following describes combining speech with an RF carrier signal?
Charlie.
Charlie?
Okay, so we talked about transceivers and transverters, power amplifiers. A lot of them have a mode switch. So you would set it to whether you're doing single sideband or CW or possibly FM because it has to do with the duty cycle. Receivers, most important things are sensitivity and selectivity. Later on in the general and extra classes, we'll talk more about intermodulation and things like that, which are also important. RF preamplifiers can be external, installed between the antenna and receiver, or it could be a feature in the radio where you can turn them on or off. Mixers are just frequency converters, basically. So you can convert a signal up to a different frequency, either higher or lower. In the case of receiving, you normally go and convert it to a lower frequency. When you're doing transmitting, you're taking a low frequency signal and converting it to a higher frequency signal. We use an oscillator to generate those signals, like the carrier. And we use a modulator to combine the speech with the carrier signal. Again, it's essentially a mixer. So we're creating a combination of the carrier and that speech signal.